Now let us start with our next non-traditional machining process, that is electro discharge machining, that is EDM. Okay, so basically EDM is the thermoelectric process of material removal. The use of thermoelectric sources of energy in developing the non-traditional technique has greatly helped for achieving the machining of very difficult materials which are having low machinability. Okay, and of course for difficult job they help us for uh, getting the removal of material from such a kind of workpieces. Now this EDM process actually is the material removal by the controlled erosion through a series of electric sparks, commonly known as the electric discharge or electric discharge machining, and was first started in USSR in around 1943. And the onward research, we can see the development has brought this process to at present level. The very next generation of this EDM as a wire cutting EDM, okay, which are basically used for cutting the uh, various complex profiles in the sheet material, also in the dies. You can see the basic scheme of this process is there is a tool. Tool is having or given a feed with the servo control mechanism. This is the workpiece which is mounted on the fixture plate is mounted on the base, and the entire setup including this tool and this workpiece is immersed in the dielectric fluid. Okay, and see the tool and workpiece is connected to the electric generator, and when the discharge is taking place at the tip of the tool or between the 2 points, that is anode and cathode, the intense heat generated near this spark and the near material will get melt and evaporate. Now for improving this effectiveness of this uh, sparking zone, rather you can say, the tool as well as this material is immersed in this dielectric fluid. Okay, so actually this dielectric fluid is used for improving the effectiveness. Now the dielectric fluids may be the hydrocarbon or mineral oils we are using, but most commonly used the dielectric is the kerosene. Now you can see here, if the diagram is clear, we will move ahead in this process. See, EDM process is also called as a spark erosion machining, where the material is controlled by a controlled erosion we already discussed through a series of electric spark known as electric discharge machining. It is high voltage and low current process. During major portion of the cycle, capacitor banks charges, and once voltage reaches a threshold value, all capacitors will discharge simultaneously, producing the spark at the tip of the tool. Now see here, basically major cycle time for this EDM is utilized under the charging of capacitor bank, and the sparking time or the discharging time is very less compared to the charging time. It is around 10% of your charging time. Please remember this. Okay. So dielectric becomes conductive only in the region when sparking occurs and heat generated at the interface of tool and workpiece. Now by using the heat, the workpiece material is melted and evaporated. We also discussed to increase the evaporation efficiency, or you can say effectiveness of this process. The tool as well as work is immersed in a dielectric fluid. Now another mechanism which also help for getting this process done is that is cavitation. Now because of evaporation is taking place inside the liquid and vapors are continuously coming out at the sparking zone, where pressure falls below the partial pressure of water vapor in the atmosphere. Because of that, the pressure falling below the water vapor in the atmosphere, so definitely cavitation or bubble formation will occur in the sparking zone. And because of this, one more phenomena in the process, the mechanism by which the chip formation is occurred in the EDM is by melting and vaporization along with cavitation. Okay, so please remember, melting and evaporation is there, already we discussed, but along with this mechanism, one more mechanism we can add here, that is cavitation. Okay, or the process is also known as spark erosion and cavitation. Please remember this spark erosion and cavitation. This is also mechanism of EDM. Melting and vaporization with cavitation. This is also the mechanics or mechanism of EDM. Now let us talk about the tool material which is used in the electro discharge machining process. So tool, or this is also known as electrode. So what are the characteristics of this electrode to serve as a good tool? So it should be good conductor of electricity and heat. Of course, electrical process is there, so it should be conductor of electricity and heat. It should be easily machinable so that it can be get converted into a required shape, and of course with a reasonable cost it should get. It should be efficient enough to have the maximum material removal rate from the workpiece. Then it should resist the deformation during the erosion, otherwise the wear of the tool will take place, and that is not acceptable actually, because it will hamper the wear ratio. Wear ratio we already discussed, that is volume of material removed on the workpiece divided by volume of tool worn out. So that's why we need minimum wear on the tool so that the wear ratio is maximum. Then it should have low electrode wear. Yes, we discussed this. It should be available in the variety of shapes. Then we are using various electrode materials like graphite, copper graphite, brass, zinc alloys. Then we are having copper tungsten alloys. Then we are having silver tungsten alloys. Out of these, we will discuss some tool materials or electrode materials like copper. So here copper is, or is also known as electrolyte grade copper, is extensively used as electrode material. It is most often used when the fine finishes are required in the workpiece. So copper, a certain grade, that is pure copper or electrolyte grade copper, which will give the benefit of fine finish on the workpiece, and it is also excellent for no wear EDM, that is tool wear is very low. But only the problem in machining of copper is that copper is having poor machinability. So when we made a electrode or tool from the copper, the only thing is that it is quite difficult to shape in a required manner. Okay. So next tool is, or electrode material is, brass. So free machining brass is often used in the electrode material. They are easily available and can readily machine easily. It is often used for tubular electrodes in specialized small hole EDM drilling machines where wear is acceptable. Also, the graphite is used as a tool material or electrode. So it is most widely used EDM electrode material because of good machinability and wear characteristic. Graphite permits fast material removal rate as well as best wear ratio. See, wear ratio is very important, and whichever tool is giving best wear ratio is welcome in the process. Okay, and also have this stability. This graphite is having excellent stability. After the discussion on the tool material, Let us have some discussion on the dielectric fluid which can be used in the EDM process. So as we know that dielectric fluid is doing that, it is increasing the efficiency or effectiveness in the sparking zone. Okay, so it is a spark conductor, it is a coolant, and it is a flushing medium also. Please remember, dielectric is not only a spark conductor, but it is behaving like a coolant and also a medium for a flushing of the cheapest produced in the EDM process also. So what are the requirements of the dielectric? So it should have low viscosity, it should be non-toxic, it should be chemically neutral, it should be highly inflammable, and of course it should have a low cost. These are the requirements, or rather you can say the characteristics of the dielectric fluid. As I mentioned to you, the most commonly used the dielectrics are the hydrocarbons or the mineral oils, but kerosene is most popularly used dielectric fluid. So here see, the ordinary water possesses almost all these properties, but since rusting is there when we use the water, so this is not suitable actually for machine elements or machine parts. So that is not used. The most commonly used type of fluid is the hydrocarbons, then kerosene, liquid paraffin, and silicon oils are used as a dielectric. See the applications of EDM. So there is no physical contact between the tool and workpiece, and no cutting force acting on the workpiece. We will get the infinite wear ratio. Now even fragile workpiece can be machined using this process. These are the applications of EDM. If you look at the advantages, so any complex shapes required in dies and molds can easily be produced with the required degree of accuracy and finish. So most popular application or advantage of this EDM process is die sinking. Please remember. So to cut the various shapes, complex cavities in the die, we use the EDM process. And the next advantage is that the process is not affected by the hardness of workmanship. So regardless of the what is the hardness of the given workpiece, to do the machining operation, it is performing best. Okay. Now since there is no cutting force acting on the tool, high aspect ratio surface can be machined. Then the process is generally highly automated with very little operating skill required, and the surface finish produce is better. If you look at the disadvantage of EDM, so workpiece material must be electrical conductive. Then the perfect square chord holes cannot be produced, as when we are going for perfect square holes, so at the corners of the holes there is a hardening effect, so we cannot able to machine this exact square cornered holes. That is the thing. When forced circulation of dielectric fluid is not possible, we will get the low removal rates. Then high specific energy consumption is there, and surface tends to rough for larger removal rates. As we goes on increase in the MRR, the surface quality tends to decrease. So these are the disadvantage of EDM process. Thank you so much. We will discuss the remaining process in next video.